Friends, in this session we will understand what are algebraic expressions. Our friend Raghu is given a good opportunity by his parents. On planting saplings, Raghu's parents would reward him in the following manner. If he plants up to 3 saplings in a week, they will give him 4 chocolates for each sapling. And if he plants more than 3 saplings, then he will get 2 chocolates for each extra sapling that he plants. Raghu thinks how many chocolates he will get if he plants 2 additional saplings in the first week. Can you answer this question? We know that on planting first 3 saplings, he will get 4 chocolates per sapling. Hence, he will get 12 chocolates for planting 3 saplings. Now he will get 2 chocolates for planting each additional saplings, which means he will get 4 more chocolates for these 2 additional saplings. So Raghu will get a total of 16 chocolates on planting 5 saplings. Similarly, what if Raghu plants 4 additional saplings next week? For the first 3 saplings, he will get 12 chocolates, and for the additional 4 saplings, he will get 2 chocolates per sapling. This way, Raghu will get a total of 20 chocolates. What if Raghu plants 7 extra saplings in the third week? He will get a total of 12 plus 2 times 7, which is equal to 26 chocolates. Now look carefully at these 3 calculations. Do we see any pattern? In each calculation, everything is the same except for 2, 4, 7. These numbers are the number of extra saplings Raghu has planted. Now, if we replace the number of extra saplings with letter X, we will get this. X is the number of additional saplings planted. We know that here X is called a variable. 12 plus 2x is called an expression or an algebraic expression. Expressions are formed by variables and constants. So, we can say that this expression is formed by x multiplied by 2 and the constant is 12. So now, this expression makes it easy to find the number of chocolates that Raghu got. We have to place the number of additional saplings planted by Raghu in place of x. On the basis of the value of the variable x, the value of the expression will change. Let's understand some points about algebraic expressions. Suppose we are given 2 expressions. What do you think? Expression A is greater than B or B is greater than A? The easiest way to find this is to use the number line. Yes, we can represent an expression on the number line. Let's represent the sum of x and 10 on the number line. Let us assume that variable x is positioned here on the number line. Therefore, x plus 10 will be positioned 10 units ahead of x. Let's represent x plus 10 with the letter P. In a similar manner, we can represent x plus 12 on the number line. It will be 12 units ahead of x. Here, the value of x plus 12 is represented by Q. Here we can see very clearly that point Q lies ahead of point P. It means that the sum of x and 12 is greater than the sum of x and 10. This way, we can compare the expressions by representing them on the number line. Today, in this session, we saw what algebraic expressions are. In the next session, we will see some more examples and understand the elements of algebraic expressions. In the last session, we learnt about algebraic expressions. Friends, in this session, we will learn some elements of algebraic expressions. They are terms, factors, coefficients, like and unlike terms. Take a look at the given expression. We can see here that the expression has two parts. Here, 2x is the product of 2 and x, and then 12 is added to it. We saw in our last video that an expression has various parts which are formed separately at first and then they are added to one another. These parts are called terms. So there are two terms, 12 and 2x, in our expression. Now take a look at this expression. Can you tell me how many terms are there in this expression? And what are they? This expression is formed by the combination of four terms. 4x square, xy minus y cube, and 2. We see that the third term is minus y cube and not just y cube. We studied in our last session that it is necessary to include a minus sign in a term. Now, look at this expression. This expression has only one term. This is a product of minus 12 a, b, c. So we can say that minus 12 a, b, c are the factors of this expression. Now let's look at these four factors. The first factor, minus 12, is a number. So we call it a numeric factor. And the remaining three factors, a, b, c, are variables. And we call them algebraic factors. Numeric factor is known by yet another name. Numeric factors are commonly known as coefficient. So, minus 12 is the coefficient of this term. Now that we have understood what are algebraic factors, now let us try to understand the two types of terms, like term and unlike term. Two terms are said to be like terms when their algebraic factors are the same. And when the algebraic factors of the terms are not the same but different, then they are known as unlike terms. Let us understand it with the help of examples. Suppose 7xy and 15xy are two terms. Are they like terms or unlike terms? Remember, in order to know the type of term, we have to see their algebraic factors. In other words, the variables and not the numbers. X and y are the algebraic factors of these two terms. Hence, we can say that they are like terms. But what about these terms? Are they like terms or unlike terms? In both the terms, there are the same variables x and y, but in 3x square y, xxy are the algebraic factors, and in 3xy cube, xyy are the algebraic factors. Hence, these two are unlike terms as they have different algebraic factors. On the basis of the terms present in an expression, we can classify the expressions. Expression which has only one term is called a monomial. Here are some examples of monomials. An expression which has two unlike terms is called binomial. Here are some examples of a binomial. Similarly, the expression with three unlike terms is called a trinomial, etc. In general, an expression in which one or more terms are present and the coefficients of which are non-zero is called polynomial. These are some examples of polynomials. Today, in this session, we have learned about the parts of an algebraic expression. In the next session, we will see some common mistakes related to algebraic expressions. In the last session, we learnt about the elements of algebraic expressions with examples. Friends, in this session, we will take a look at some common mistakes related to this concept. Look at this expression. How many terms are there in this expression? Perhaps you may think that there are two terms here, but this expression has only one term, which is 4x. Here, 4 is multiplied by x. We generally make the mistake on seeing two elements getting multiplied. We think that the expression has two terms. But that's not the case. This expression has only one term. Then what about 4 divided by x? How many terms are there in it? Here, a number is divided by a variable. But still, it will be considered as one single term. When variables or constants are multiplied or divided, then it is considered as one term. Only addition and subtraction separate the terms. Suppose we are given this expression. Can you tell me how many terms this expression has? I can give you options in order to make it easier. Seeing this expression, we might guess that there are 4 terms present in this expression, but this is wrong. Look at the first and the last part of this expression. Both of these terms are like terms because both of them have the same algebraic factors, which are a and b. That is why, by adding both of them, we have to make one term. That is why, in total, this expression has 3 terms. Hence, the correct option is B. Remember, before counting the number of terms, we have to keep in mind that all the terms should be unlike terms. If we have like terms, then we should reduce them to one term either by adding or subtracting before counting the number of terms. In this session, we have seen 2 mistakes related to algebraic expressions.